Okay, students, let's go over your practice quiz here. Here's your f of x and your g of x given to you. 1a says just to add them together, f plus g of x. Okay, so just add the two together. Let's line it up vertically under like terms and add straight down. Number 2 says to subtract f minus g. So I put the f here, and then I already went ahead and distributed the negative through the g here. That's why it's negative x minus 3. And just add it straight down. 1c says to multiply. So again, set up vertically, multiply, automatically line up your like terms, and then add straight down to combine like terms. 1d is division, so that's since you're dividing by g, you can use synthetic division. That root is negative 3. You write down the coefficients, 1, negative 5, and 1. If there were missing terms, I'd have to plug in a 0, but there are none because it goes degree 2, degree 1, degree 0. So no missing terms there. So 1, negative 5, 1. Okay, remember you drop the first one down, so it just is 1. Okay, should have been a 1 there. And then negative 3 times 1 is negative 3. Add them. It's negative 8. Negative 8 times negative 3 is positive 24. 1 plus 24 is 25. This last one is your remainder. Okay, so that is 1x minus 8. Should have been x minus 8, not x squared. Okay, good thing I'm going over that here. You're always going down by a degree, so you see this was degree 2. So the top it's going to be is degree 1. Okay. Oops. All right. So now you have to remember on your remainder, it's x minus 8, and then since this is a plus 25, it's plus 25 over what you're divided by the x plus 3. Okay, so don't forget to put the x plus 3 in the denominator for the remainder. Okay, 2. Here's our f of x and g of x. So this is f of g of x. Remember, that's function notation, so we go right to left. Stick the g into the f where you see an x. Anytime you see an x, you stick that whole g function into it. So I have negative 2x plus 5, and then I have a minus 2 at the end there for this minus 2 here. Don't forget that. That's a common piece left off. And there's nothing to distribute, it's just a 1 here. So I can just take off the parentheses and then combine like terms. So I have negative 2x plus 3 is my answer. So the f of negative 2x plus 5, that means that's what I'm sticking into the x, is the negative 2x plus 5, which was that g function. Okay, 2b is going in the reverse direction, g of f. So it says take the f function, plug it in, the f function, plug it into the g function every time you see an x. So there's only 1 here, right there. So I have negative 2. When I substitute in, I always put parentheses around it. So x minus parentheses, x minus 2, parentheses, and then the plus 5 at the end. Again, don't forget the plus 5, common error. Now I distribute negative 2x plus 4, and plus 4 and a plus 5 is a plus 9. It's very simple. I'm giving you simple problems on your quiz. Okay, you might see a little more work on your test, but on a quiz, making it easy. Okay, find the inverse of the following. Inverse, remember f of x is basically like a y. So for find the inverse, we switch the x and the y. So that x goes over there and that y comes into that spot. And that's why you see x equals negative y plus 4. And now we solve for y. So since this is a negative y, I want to move it over to the other side to make it positive y, which means subtract the x across. I get y equals negative x plus 4, and then I substitute that y back in for f inverse of x. Okay, that's a f to the negative 1 if you can't read it. Okay, so you put it back into the function notation. Okay, and same idea for b, except for I just simplified this 3/6 down to 1/2. I switch the x and the y. And I need to solve for y. Since this coefficient is positive, I'm going to leave the y on the right side. So add the 4 across, you get that. Then I need to get rid of the 1/2, so I multiply the whole thing by 2. That gives me 2x plus 8 equals y. And now I go ahead and substitute back in the f inverse of x. And there's my answer. Number 4, I need to determine whether each pair of functions are inverses. Okay, so in order to determine that, I have to do the f of g of x. And if that comes out to be x, then I need to switch into the g of fx and see if that comes out to be x. If they're both x, 1x exactly, then they are inverses. So that's the work you must show. So on this top line, I did f of g of x. So I stick the g function and substitute in for that x right there. And that's what you see right here. Then I distribute the 3/2 through there. Well, that cancels that out right there to x. Okay, and then 3/2 times -6 is -9, and then the 9 minus 9 is 0, so I left with just x. So that came out to be x. Now, if it wasn't x, I did the work right, it wasn't x, then it's not, I can stop right there. I don't have to do the reverse one of g of fx. Okay, they both had to come out to be x. So if one comes not out to be x, then boom, you're done. Right there. Just make sure you do the right work first. Okay, so now we go to the reverse direction. Okay, so now I'm sticking f into g. I take this and plug it into there. Okay. Looks like I didn't show the work for that. I must have just did that in my head. Okay. We'll stick it down here. I'll stick it down here. Okay, so I have 2/3 parentheses 9 plus 3/2 x, and then a minus 6. So I distribute that. 2/3 of 9 is 6, plus 2/3 and 3/2 cancel, x, and then minus 6. And I can see 6 minus 6 cancels out, and I get x. And so that's a yes, that they both count to be x, so therefore they are inverses. Okay. Oh, I see where I did it over here. I did show it. Let's put it over there. Okay, so this one was here, and then the g of fx is over on this side. Okay, graph each function, states domain and range. So not only you have to have a graph, you have to have domain and range. Okay, the graph is the easy part, because again, you could also plug that in your graphing calculator. But underneath radical x plus 2, that just means set that equal to 0, and so x equals -2. So therefore, you shift it to the left, -2. So that's why I started at -2, 0. Okay. And then if there's a plus or minus a y at the end here, that would shift it up or down, but there's not in this case. Okay. Now we graph it. Well, the normal one will be shallower, but this says do 3 times it, 3 times every y coordinate. You plug in graphing calculator, I could sit there and make an x, y, t chart. Okay, and I'd pick nice numbers like -2, that gives me a 0. 0 times 3 is 0. So it's the -2, 0. Let's say I said 2, because 2 plus 2 is 4. The square root of 4 is 2 times 3 is 6. So at 2, it should be up there at 6. I pick the next perfect square. That's going to be 7. 7 plus 2 is 9 for the perfect square. Square root of 9 is 3 times 3 is 9. So 7, 9. Okay, and then I just go ahead and graph it. There we go. Now domain. Domain are all the x values graphed. All the x values graphed are from x equals -2 and beyond to the right. So you can write this, or you can write -2 bracket parentheses to infinity. Your choice. And what are the y values graphed? They start at 0 and gone up to infinity. So the other way would be bracket 0 to infinity. Around infinity is only always a parentheses. You can never have a bracket around infinity because infinity never ends. or a bracket means it ends or stops or starts there. So it's always a parentheses around infinity, positive or negative infinity. Okay, so I'll take either format. Um, okay. Next, so find radicals here. Cube root. Take the cube root of 64 is 4. 4 times 4 times 4 is 64. For my exponents, I just divide them. 10 divided by 3 is 3, so I have a cubed on the outside with the remainder of 1. The remainder goes back inside. And then b to the 18th, 18 divided by 3 is 6 exactly, no remainder, so there's no b back inside. Don't forget when I write this root that I have left, the remainder, it has to have that 3 there. Otherwise, it means 2, and it would be wrong. All right, next one. Fifth root of negative 243. That's negative 3. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3 is negative 243. Again, 7 divided by 5 is 1, remainder of 2. And 5 divided by 5 is just 1. Okay, you don't have to have the ones there on the outside. You can say A and B. So no remainder on that, so there's no B's on the inside there either. Okay, and that is your quiz. Explain.